Consider the circuit shown in figure 18.9. Find A, the current in the 20 ohms resistor, and B, the potential difference between points A and B. So the first thing I did was copy the photo from the textbook, and then I'm going to find the resistance in both the series and the parallel circuits. This problem is kind of confusing, but basically because the battery is placed up here next to resistor 3, the current's going to start out by going in this direction, which means the parallel circuit actually happens between 1, 2, 4, and 5, and 3 is part of a series circuit. And if that doesn't make sense right now, it will in a moment. So I found the resistance in 1 and 2, and because it's a series circuit, you just add the two values, so you get 25 ohms. And then you essentially have this circuit where 1 and 2 are combined with a value of 25 ohms, and you're going to find the resistance of the parallel circuit between 1, 2, 4, 5. And because it's a parallel circuit, you do 1 over R is equal to 1 over R of 1 and 2 plus 1 over R of 4 and plus 1 over R of 5. And once you do the math, you find that the resistance is equal to 2.94 ohms. And then you basically have a series circuit with the R of 1, 2, 4, 5 and the R of 3. And because it's a series, you just add the values and you find that R of the entire circuit is 12.94 ohms. Then to find the current, I did V equals IR, and V is 25 volts and R is 12.94 ohms, which means I is 1.93 amps. I then did part B before part A because it made more sense that way. But anyways, to find the potential difference between points A and B, you're finding the voltage between those points. So you do V equals IR. I is 1.93 amps, and you're going to use the resistance between 1, 2, 4, and 5, which is equal to 2.94 because the current is running through that parallel circuit. And so you find that V is 5.68 V. And if you do the math using these numbers, you're going to get 5.67, but I use more exact numbers, which is why it's 5.68. And then I did I equals VR, which is basically this equation just manipulated to solve for I. And I did 5.68 V over the resistance of 1 and 2, because in part A, you're finding the current in the 20 ohms resistor. So then after doing the math, you find that I is 0.227 amps.